Hello champions, welcome to the next lecture on the numerical solutions to the ordinary differential equation. Today I will explain you the idea of the Picard's method to solve the first order first degree differential equations. What is the objective of this lecture? We will see how you can find the solution of the ordinary differential equation, and we will see the various examples until we will get the easiest way to learn the concept. Myself, Dr. Harish Garg, you can follow and subscribe my YouTube channel where you can find the playlist of the ordinary differential equation. In this playlist, you can see the various lectures such as the Bernoulli equation, homogeneous, exact equations, integrating factors, and many more lectures in this playlist. The last lecture we have seen is related to the Taylor's method for finding the numerical solution of the ordinary differential equations. Now, as we have seen how we can find the initial value problem, once you have the initial value problem, your target is to find the approximate solutions. We have the different 5 methods. The first method we already discussed in our last lecture. Now, in this lecture, we will cover the concept of the Picard's equation method. As I saw you, you can watch the previous lecture related to the Taylor's method. Now, in this lecture, we will see how we can solve the Picard's equation method. The Picard equation method is also known as the Picard's method of the successive approximations. What is the objective of this Picard's equation methods? Whenever we have seen the first order differential equations, in our last lecture, what we have seen, we have learned the concept of the Taylor's method. And what we did in our Taylor's method, we have find the second derivative from the given, this is my y dash, fine. We can find the third derivative, we can find the fourth derivative, and so on. That means we can differentiate equation number 1 in the Taylor's method, fine. Now, on the other hand, in this lecture we will see how we can apply the Picard's method. Instead of the derivative, we will apply the integration on the equation number 1. So if you apply the integrations with respect to x on equation number 1, what will happen? If you look about the left hand side, that number will be my yx minus y of x naught, which is equal to integration from x naught. X naught is my initial point, fine. X is my target point, x comma y dx, fine. What is the value of the y of x naught? Y of x naught is given as a y naught, so we can find the value of y at the given point. X is y naught plus integration from x naught to x f of x into yx. Make sure students, since we are applying the equation methods, the exact form, or you can say the explicit form of the function f is not given to us, or we never know how you can find the function fxy. Then in that case we will apply the approximations. How you can do the approximation? The first approximation is we can substitute. As I mentioned you, we never know the explicit form of the functions. So once we never know the explicit form, we will always apply the approximate methods, or called as the iterative methods. Now, in order to apply the iterative methods, we will start by substituting the value of the y is y naught, fine. Then we will get the first approximation, y1, which is equal to y naught plus integration from x naught to x f of x comma y naught, where f of x comma y is given to us. For example, if I say dy over dx is x plus y, then your x plus y is my f of xy. Make sure students, the coefficient of the dy over dx must be 1. It must be 1, fine. Now once you know the first approximation, you can find the value of the y1, and then you can substitute the value of the y is equal to y1 in the equation number star. We will get the second approximation, which is defined as y naught plus, you can see the value is my y1. Similarly, we can find the third approximation, y3, which is equal to y naught plus integration from x naught to x comma y2, and so on. And similarly, we can find the nth approximation, which are defined as x comma y of n minus 1. But make sure students, in all these nth approximation, we always need to compute the integrations. So the Picard's iteration methods or the Picard's successive iteration is defined as y of n is y naught plus integration from x naught to x f of x comma y of n minus 1, where n start from the 1 to end. So now once you can define the successive approximation y1, y2 and so on up to yn, fine. Now the question arises is whether these successive approximations are converges to the unique solution or not. If it is converges to the unique solution, then under what condition? There are the two conditions. The first one is whatever the function of the f you have, that must be continuous. And second is partial derivative with respect to y is also continuous. Fine. Once these two conditions are satisfied around the given point x naught, y naught, then you can say the approximations you have find y1, y2, yn is convergence to the unique solution. Make sure students they are converges around the point x naught, y naught. I will explain you with the help of the examples what is the meaning around the point x naught, y naught. Now the few remarks that I have put up for you in case of the competition exams or in terms of the analysis. The Picard's method is more theoretical value than of the practical values, but make sure since the Picard's method is totally based on the integrations, so we can say the method is applicable only when you can easily obtain the integrations. But we all know if you have the functions such as 2 minus x or log sine of e raised to power minus x square and so on, then it is a very difficult for us to find the integration of the function fx. In that case, the Picard's method is not an easy target to find the solutions. The Picard method is also applicable once you are using for the higher order derivatives. In this case, you can see y and z both are my dependent variable, or you can say this is the system of the equations. Fine. So I will explain you all these concepts with the help of the 15 plus numerical examples in this lecture. So let's start with the first question. Now clearly say the coefficient of the dy over dx is 1. What is my f of x comma y? F of x comma y is x plus y, and the initial point x naught, this is the value of the x naught, and the value of the y naught is my 1. Now clearly say the function f is continuous about the point 0 comma 1. Yes, the function is continuous about the point 0 comma 1. Moreover, if you find the partial derivative, that is my 1, which is also continuous about the point 0 comma 1. So therefore, yes, this solution, the solution is converges to the unique solution. Now how many approximation you needed? In the given statement they are asking about the 3 approximations, so we can compare and we will get the value of the f, x naught, y naught. By using the successive approximation we will get yn is y naught. What is x naught? Is my 0, so I can substitute the value. What is the y naught? Y naught is my 1 plus x naught is my 0. What is the value of the f of x? So I can substitute x plus y of n minus 1 into dx. Fine. Now we can start with the first approximation. The first approximation means we can start with the y1. So what is the y1 is? It's a y0. So that means 1 plus integration from 0 to x, x plus y0. What is the value of the y0 is? 1. Fine. Now can you integrate them? This number is my 1. Integration from 0 to x, it's x square by 2 plus x. Fine. Now you can find the value of the y2. What is the value of the y2 is? 1 plus integration from 0 to x, it's x plus y1, and the y1 we have obtained is 1 plus x will be, let's say, 2 of x plus x square divided by 2 of dx. Now if you solve them, if you find the integration, that will be my x square plus x cube divided by 3 into 2, from 0 to x. If you substitute the upper limits and the lower limit, you will get the answer is 1 plus x square plus x cube by 6. Similarly, for the y3, you can integrate from 0 to x. It is x plus y2 because this number is my y2. So that number is 1 plus 2x plus x square plus x cube divided by 6. Now if you integrate them, you will get the answer is 1 plus x square x cube by 3 and so on. Because in this case, your target is to find the 3 approximation. That is the required answer of the problem. Look at the second one. Apply the Picard's methods and show that the solution converges to the exact one. What is my f? F is nothing but y, and clearly say this function is continuous at what is the initial point is x will be 0 and 1. Fine, yes, it is continuous. What is the partial derivative with respect to y? Which is 1, which is also continuous. So therefore, the whatever the Picard's equation you have obtained, that will converges to the unique solution. And he said the unique solution is e raised to power x. So let's start with the given functions. We can apply the Picard's equation methods. So let's start with the first approximation. I can substitute the value of the f of x minus x comma y minus 1. So what is the first approximation? y1. y0 plus integration from 0 to x. What is the y of 0 is? 1. And your answer will be 1 plus x. Fine. So first integration is 1 plus x. Now you can substitute in the second one. It's a 0 to x y1. y1 is 1 plus x into dx. So if you integrate them, it is 1 plus x square divided by 2. Integration from 0 to x. That number will be 1 plus x square over 2. Fine. Similarly, you can find the value of the y3. y3 is nothing but 1 plus y2. I can substitute the value of the y2. If you integrate them, that comes to be here. Fine. And similarly, if you go and move further, so you can see it's a y2, then it's a x square divided by 2 factorial. y3 is x cube divided by 3 factorial. And if it is xn, you can say this number is my xn divided by n factorial. And you are very surprising to see ये किसकी series है आपके पास? This series is nothing but e raised to power x up to the finite terms. Fine. Now, how you can find the exact solution? Fine. Now we can find the exact solution. As limits n approaches infinity, you will get the solutions. But the question arises is how we can find the exact solution. We can apply the either as the homogeneous method, variable separable methods, or any more. Fine. So I can use the variable separable method. Fine. Then we can integrate. This equation becomes log of y, which is equal to x plus c. So as we can apply the condition, y of 0 is equal to 1. So which implies log 1 is 0, x is 0. So that implies c is equal to 0. Therefore, this equation becomes log of y is equal to x. So my exact solution is y is equal to e raised to power x is my exact solution. And you can see once we know y is equal to e raised to power x is the exact solution, and the Picard's method also converges to the exact solution. Fine. So I can show you, we can use the variable separable methods, we can integrate them, and we can get the exact result. Okay, find the value of the y at the point 0.1 by using the Picard's method. Fine. So given function is my f. Fine. Now clearly say the function y minus x over y plus x is continuous at the point 0, 1 because function infinity नहीं जा रहा आपके पास. Fine. So let's start with the Picard's equations. I can substitute the value of the f of x comma y of n minus 1. That number is y of n minus 1. Fine. So let's start with the first approximation. So let's start with the y1, which is y0 plus integrations from 0 to x. What is the y of 0 is? 1 minus x over 1 plus x. Fine. How you can integrate them? Because the degree of the numerator and denominator are same. So in order to find the integration, I have to simplify the equations. So I can write as minus 1 plus 2, 1 plus x. Fine. Now you can integrate them. It is 1, then minus of x plus twice log of 1 plus x from 0 to x. Then you can substitute the upper limit. That number will be minus x plus twice log of 1 plus x. And if you substitute the lower limit, 0, log 1 is 0. Fine. So your answer is 1 minus x plus twice log of 1 plus x. That is the result of the y1. Now you can find the value of the y2. I can substitute the y2 will be 1 plus integration from 0 y1 minus x y1 plus x. Fine. I can substitute the value of the y1 at the given integrations. Fine. So you will get this result. Now how you can integrate them? Again, you can see it is 1 plus, I can make that these two pairs. So that will be 1 minus 2x divided by 1 plus twice log of 1 plus x. ये लिख सकता हूँ ना इसे? Fine. Now how you can integrate them? The first integration is simple. One integration is x. But you can look about the second term. The integration of the second term is not an easy target. Fine. क्या आप इसकी integration कर सकते हो? Will it possible for you? You can find the integrations? No. Fine. So since the integration of the second term is very difficult, we can find the value of the, because we already obtained y1. Fine. We already obtained them. So I can substitute x is equal to 0.1 in the given value of the y1. So this is my y1. So therefore at x is equal to 0.1. y1 of 0.1 will be 1 minus 0.1 plus twice log of 1 plus 0.1. You can use the calculator and get the answer is 0.9828 is the right answer. Look at the next one. I hope you can like and comment on the video. So it's a y dash. Y dash means it's a dy over. Apply the Picard's equations. What is your function is? 2x 1 minus y. Initial point is 0. Y of naught is 2. Then by using the Picard's method, we can start from the initial point is my 0. 0 to x f of x comma y of n minus x. Fine. I can substitute y naught is my 2. Find what is the f of is 2x 1 minus y of n minus 1. Fine. So let's start with the first approximation. So y1 twice plus integration from 0 to x 2x. What is the value of the y naught? Y naught is my 2. So 1 minus 2 is my minus 1. So can you integrate them? That number will be 2. It will be my minus x square. 2 and 2 will be cancelled from 0 to x. Answer is 2 minus x square. Fine. Can you find the value of the y2? Is a 2 plus, fine. So it's a twice plus 0 to x square, 0 to x, 2 of x. It's a 1 minus y1. This becomes 1 minus y1. If I substitute y1, answer will be minus 1 plus x square. Fine. So how you can integrate them? So you can open this bracket. It will be minus 2x plus 2x cube of dx. Now you will get 2 plus, can you integrate them? It is a minus x square plus 2x4 divided by 4 from 0 to x. So once you can substitute x, you will get the y2. Similarly, you can substitute the y3. you can get 0 to x. It's a 1 minus, it's a minus x, 1 plus x square minus x4 divided by 2. Fine. So what is the integration? Twice plus first term will be minus of 2x. If you integrate them, it is minus x square. It's a twice x cube. If you integrate them, it's a twice x cube by 4. So x4 by 4. Fine. If you integrate them, it's a x4 divided by 4. It's a minus x5. x5 will be x6 divided by 6 from 0 to x. If you substitute the upper limits and the lower limit, you will get the answer is, I can write as a 6 is 3 factorial. Fine. Now if you look more clearly, this expression is, if I write as a 1 separate, fine, then it's a 1 minus x square plus x4 divided by 2 factorial x6 divided by 3 factorial and so on. तो ये कहाँ जा रही है सीरीज आपकी? What is that part? That is nothing but e raised to power minus x square. Fine. So you can write as a y of n is 1, because यहाँ पे approximation कितने बोले? They are not given to you. So we can find the nth approximation that will give you e raised to power minus n square as limit n approaches infinity. And yes, it converges to the unique solution. Fine. Why it converges? Because you can see the function is continuous. Fine. What is the partial derivative with respect to y? It is my minus of 2x. And yes, at the point of the 0, the function is continuous as well. So yes, it will converge to the unique solution. Look at the another one. Your target is to find the third approximations. Again, f is given to you, x naught and y naught given to you. Fine. And your target is to start with the approximations. So let's start with the y1. So what is the y1 is? Because y naught is my 0. Fine. So it's a 0 plus, is I can start from the integration. 0 to x. What is the y0 is 0. So the first part is only x. So that will goes to the x square divided by 2. You can look at the second part, y2, second approximation, x plus x square divided by 2. So what is the integration? If you do the integration, it is x square divided by 2 plus x cube divided by 6. 6 I can written as a 3 factorial. Similarly, you can find the y3. Sorry, it's a y square. So y square karoge, so that number is whole square. Fine. So if you take and the whole square, that becomes the x power 4 divided by 4. Fine. And then you can integrate them. Similarly, for the y3, you can substitute whole square. So that will be 0 to x plus y2 x5 divided by 20 whole square into dx. Fine. Now you can open this bracket, a plus b whole square. So a square plus b square plus 2ab. So it's x raised to power 5 and 2 is 7. X raised to power 7 divided by 20. Fine. Now you can integrate them. Your answer will be x square divided by 2. This is x raised to power 5 over 20. This is x raised to power 11 divided by 4400. And this is x raised to power 8 divided by 160 is the right answer of the problem. Since there are required only the 3 approximations. अगर y4 भी पूछा जाए, then you can do it y4 as well. Now find the 2 approximations only. So let's start with the given. What is the y of n? Y naught plus starting limit is 0 to x f of x plus y of n minus 1 square. Fine. So let's substitute the one by one value. What is the y1? You can substitute the value of the y naught. It's a 0 square. 1 square is 1. What is the integration is 1 plus e raised to power x is e raised to power x plus x from 0 to x. That value will be 1 upper limit minus e raised to power 0 is 1. So 1 and 1 will be cancelled. It is x plus e raised to power x is the first approximation. You can start with a y2. y2 is 1 plus e raised to power x plus 1x plus e raised to power x whole square. Fine. Now you can open this bracket. 1 plus integration from 0 to x a square plus b square plus 2ab, fine, into dx. Clear? Now I can write for here. Now the first expression becomes, now you can find the integration. First integration is e raised to power x is e raised to power x. X square will be x cube by 3. E raised to power 2x will be e raised to power 2x over 2. And how you can find these integrations? Fine. Either you can use as a Eilert formula, fine, or you can use as an integration of the uv, fine. That is the first function, integration of the second function minus derivative of the first function, integration of the second function. But I will tell the easiest way because our target is to find, fine. तो इसको दो पार्ट्स में ब्रेक कर लीजिए आप. फर्स्ट पार्ट इज माई पॉलिनोमियल, इसमें कोई पॉलिनोमियल है, द पॉलिनोमियल टर्म इज माई 2x एंड सेकेंड इज माई e raised to power x. फाइन. इसको डेरिवेटिव करना स्टार्ट कर दीजिए until you will get as a 0. फाइन. द फर्स्ट डेरिवेटिव विल बी 2, नेक्स्ट विल बी 0. क्लियर? और यहां पे इसका इंटीग्रेशन कर दीजिए आप. That is e raised to power x. Second integration is also e raised to power x. Now you can multiply them by here. Plus minus plus minus. So the first answer will be 2x e raised to power x minus 2 e raised to power x. So that's the integration of this portion. 2x e raised to power x minus 2 e raised to power x. Now you can substitute the upper limits and the lower limit. You will get the required answer. This number is my minus of x. Fine. And so on. Fine. So you will get the required solution is, this is the required answer. अभी एक और बता दे रहा हूं. If you want to find say x cube sin x, fine, कैसे करोगे? The easiest way is you can write as a x cube, you can write as a sin x. Find the derivative of the first part until they becomes a 0. The first derivative becomes 3x square, second is my 6x, third is my 6 and the next one is 0. Write the integration minus of cos x, इधर का आपको इंटीग्रेशन कर देना है. Fine. First one is minus cos x integration is sin x integration is again minus, so it's a minus minus plus, again integration is cos x integration is a sin x. Fine. Then you can multiply with the, fine, you can multiply them with the sign positive negative positive negative. So the answer of this problem is, first one is minus x cube cos x minus minus plus 3x square sin x, then plus 6x cos x, and it's a minus 6 sin x is the integration of the x cube sin x. Fine. Similarly, if you want to write as the integration of say for example x square e raised to power minus 3x, fine, again it's x square e raised to power minus 3x. तो इसको डेरिवेटिव कर दीजिए 2x to 0. Find the integration e raised to power minus 3x divided by minus 3, e raised to power minus 3x divided by 3 and 3 9, e raised to power minus 3x divided by minus 27. You can cross multiply it with the sign plus minus plus minus. Fine. So the answer is minus x cube e raised to power minus 3x over 3 minus 2 over 9 e raised to power minus 3x and minus 2 over 27 e raised to power minus 3x is the right answer of the problem. चलिए apply the Picard's method, find the three approximation of these integrations. You can see the starting point is my 1. So you can write as a yn is y naught. Starting point is my 1 to x. What is the f is 2 minus y of n minus 1 over x. Fine. And clearly say the function 2 minus y over x is continuous at the point 1, 2. कभी इन्फिनिटी तो नहीं जाएगा ना, ये 1, 2 पे 0 जा सकता है लेकिन इन्फिनिटी नहीं जा रहा. Now let's start with the first approximation. y1. So y2, that is a y naught is 2. Integration from 1. So what is a y0? Y0 is my 2. So 2 minus 2 over x. Can you find the integration? 2 plus is a 2x minus 2 log x from 1 to x. So that will be 2 plus 2x minus twice log of x. If you substitute 1, it's a minus of 2 plus 0. 2 and 2 will be cancelled. Answer is 2x minus 2 log x is your y1. Fine. Now you can, how many approximation? 3 approximation. Find the, substitute the value of the y1 in here. You will get the value of y2. Fine. Now how you can do that? I can make it as a separate. Fine. That will be 2 minus 2 plus 2 log x over x. Fine. 2 and 2 will be cancelled. So your part will be 2 log x over x. How you can integrate them? Fine. So if I take log of x is my t, then 1 over x dx will be dt. Fine. तो ये वाला portion क्या बन गया आपका? Your this portion becomes integration of t into dt. So that will be t square. So log of x square divided by 2 from 1 to x. Substitute the upper limits and the lower limits. 2 and 2 will be cancelled out. Fine. So that number will be log of x whole square. And if you substitute 1, that number will be 0. So your answer is 2 plus log x whole square. Substitute the value of the y2 in the given successive equations. Now we can start the third integrations. Integration from 0. Again you can separate them. 2 minus 2 over x minus log x whole square divided by x. Fine. Now how you can integrate them? For the first case, plus 2 integration will be 2x. 2 over x integration is my 2 of log x. And how you can integrate this portion? Again, if you take log x is my t, then 1 over x dx is dt. तो ये आपकी इतने portion की integration क्या बन गई आपकी? That becomes integration of t square dt. That will be t cube divided by 3. So that is a negative log of x cube divided by 3 from 1 to x. Fine. Now you can substitute the upper limits and the lower limit. If you substitute the upper limit, is a 2x minus 2 log x minus log x cube divided by 3 minus, if you substitute 1, it's a twice, log 1 will be 0, log 1 will be 0, and that 2 and that 2 will be cancelled out. So your answer is the up to the third approximation is the required answer. Now I will give you these 5 problems as an exercise. You can solve it by own and let me know if you have any doubt in this lecture. You can verify your answers in the as I mentioned you. Let me know how many of you have really solved this problem and get the same solution as I have mentioned in this slide. I'm waiting for your comment box. We will see the next lecture on the ellipsis conditions. Very important lecture for the initial value problem. Must watch it and subscribe my YouTube channel. I hope you can share this video with your friends. Like and comment on the videos. Best of luck, students. Happy learning.